Hey guys, so last time we talked about perpendicular bisectors. Today we're going to talk about angle bisectors. So the angle bisector theorem says if a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. So think about angle bisector. We're cutting the angle in half. So if AD bisects angle BAC, so look at your pictures, I'm reading this. So ray AD bisects angle BAC, it cuts it in half. And we know that segment DB is perpendicular to ray AB. And we know that segment DC is perpendicular to ray AC. Then we know that DB equals DC. They're the same length. The converse of that says if we know that a point is on the interior of an angle and it is equidistant from the sides of the angle, then it lies on the bisector of the angle. So the converse says if DB is perpendicular to ray AB and segment DC is perpendicular to ray AC, and we know that DB equals DC, then we know that ray AD is the angle bisector of angle BAC. So find the measure of angle CBE. This is how we're going to put this into use here. So I see right away that I have those right angles where they're supposed to be, and I see that CE and DE are both equal to 21. So then I know that it should be, that BE should be the angle bisector, meaning that this angle and this angle should be the same measure. So then angle CBE should measure 31 degrees. Okay, for what value of x does P lie on the bisector of angle J? Well, if it's supposed to be on the bisector, then those two segments should be the same length. So we set them equal to each other. So x plus 1 equals 2x minus 5. So I'm going to subtract 1x from both sides. And I get 1 equals 2x minus 5. Or sorry, 2x minus 1x is 1x. So equals 1x minus 5. Then I need to add 5 to both sides. So for what value of x? X equals 6. It didn't ask us to plug back in, so we're finished there. This one says find the value of x. Again, I see those two segments are congruent. I see the right angles right where they're supposed to be, so that means those two angles should be the same measure. So I have 3x minus 5 is equal to 2x plus 5. So I'm going to subtract 2x from both sides then, and I get x minus 5 equals 5. Then I'm going to add 5, and I get x equals 10. Concurrency of angle bisectors of a triangle. So if I have, it says the three angle bisectors of a triangle intersect at a point that is equidistant from the sides of the triangle. So if AP, BP, and CP are angle bisectors of triangle ABC, then we know that the three segments going to the sides, PD, PE, and PF, are all equal to each other. So that point has a special name as well. Point P in this case is called the in center. So, and it says point G is the in-center of triangle ACE. That vocab should immediately tell you something about those triangles. That if we know that we have angle bisectors coming off the vertices, then we know that all of these segments should be the same length. So if we need to find the length of BG, it should be the same as the length of FG. So in this case, BG is equal to 16. Okay, so that is all I have for this set of notes. If you have questions, please come in and see me. I'll see you in class.